Hi there, we're on 9-6 distance in the coordinate plane on page 239 in your orange algebra book. The two objectives here are to find the lengths of vertical and horizontal segments, then to find the lengths of oblique segments by using the distance formula. Okay. Alrighty, so right here, I know it's a little hard to see because I kind of messed this up, so I'm going to take this away just for a second. So we're on a coordinate plane, we're looking at a vertical line. Okay? Now, if we look here, if we just have a vertical line on a graph, our x-coordinate is the same. All right? That's not going to tell us anything. So right here, we're looking at the y-coordinates, okay? So to find the length of a vertical line segment on a coordinate plane, we use the absolute value of the difference between the two y-coordinates of the endpoints, all right? So let's set it up like this. We have our absolute, so right here I have the little example for you. Y2 minus y1, okay? So we're going to have this is our y2, and this is our y1, okay? So let's do it. Let's do 4 minus a negative 2, absolute value bars, okay? This is going to turn into a positive. So we have the absolute value of 6, which is going to be 6, all right? So the distance, the vertical distance on this vertical line is going to be 6 units. Okay? Now let's go to a horizontal line. Now again, if you notice, on a horizontal line, the y-coordinates will be the same. This one's negative 2. So we do x1 minus x2, so we're going to do negative 3. Minus 5. Okay, that's going to be negative 8. The absolute value of negative 8 is going to be a positive 8, okay? The reason why we're doing absolute values is because distance is always positive, all right? That's what we want to think about. That's why we're using the absolute value bars. Okay. Now let's go to a non-horizontal, non-vertical line, or on a diagonal, okay? So to find the length of a line segment that is neither vertical nor horizontal, you can use the Pythagorean Theorem. All right, this is how we're going to do that. We're going to create a right triangle using or drawing lines that are parallel to the axis. So let's draw our horizontal line that's parallel to the x-axis. So I'm going to draw a little dotted line here. Okay, all the way across. Okay. Now I'm going to draw my vertical line. It's parallel to my y-axis. So we're going to see where they cross. Again, this is supposed to be dashes, but the dots are not working for me right now. There we go. So it hits right here. Okay, so let's erase these bad boys. All right. That endpoint should be 5, negative 2. So we've just created a right triangle, and this is how we're going to use the Pythagorean Theorem. Okay? So our lines intersect at 5, negative 2. The vertical and horizontal segments are the legs of the right triangle, and the oblique segment, or the one that is neither vertical nor horizontal, okay, is going to be our hypotenuse. So we have our leg here. This is a leg. So I'm going to redraw over this so it's a perfect line here. There we go. All right, is everybody now seeing the right triangle? So we have a leg over here, we have a leg over here, and then we have our hypotenuse, okay? This diagonal line is known as the oblique segment. Oblique segment right there. Okay. So now we need to find the lengths of the triangle's legs, which we already have, okay? We know that our vertical line is 6 units. Okay, so we already found that, 6 units over here for this leg. Then our horizontal line was 8 units. Oopsie. Okay, so now we have our a squared plus our b squared. Now we just need to find our c squared, right, for the Pythagorean Theorem. Is it all coming back to you now? Okay, so our a squared we said, let's do that for 6. So we'll do 6 squared plus 8 squared equals c squared. All right. It's 36 plus 60, or 36 plus 64, I was right there, equals c squared. That's going to be 100 equals c squared. The inverse, we're going to take the square root of both of these bad boys. So 10 equals c. So the oblique segment is going to be 10. Okay? Units. Okay, the next piece of information we're going to talk about today is the distance formula, okay? So this comes from the Pythagorean Theorem, which can be used to find the distance between any two points on a coordinate graph, or coordinate plane. So the distance formula is where you take x2 minus x1, you square that, plus y2 minus y1 squared, and then you find the square root of that, okay? So this is a lot of information here, but we're going to play it out here on the next slide. So make sure to copy all this information down, and then we'll go on to the next slide. Okay, so I need to find the distance in simplest radical form between this set of points. Okay, so if you have your textbook open and your notebook open, you should have the formula right in front of you. All right, so let's do d equals the square root of, I'm recording. So we're going to do 3 minus 1 squared plus 5 minus negative 1 squared. So we'll put that one in the brackets. Okay? So then we're going to have d equals square root of 2 squared plus 6 squared, because this became an addition. Okay? Okay, so that is going to equal, to a different color, d equals the square root of 40. We got 40 because that is 4 plus 36, which equals 40. Alrighty? Now, we're down to this bad boy. This is not a perfect square, so let's simplify it. That is going to be 4 times 10 for a perfect square. Square root of 4 is going to be 2. So the distance here is going to be 2 square root of 10. Alright? Okay, I want you to do this next one on your own. It's going to be negative 3, 8, and negative 10, and 1. Okay? Use the distance formula. It should be in your notes because you just copied it in there, and it's also in the textbook. Okay? So when you're finished, hit play, and we'll check your answers. Alrighty, folks. So I broke this down for you guys. So your work should look pretty similar to my work. The distance between those 2 points is going to be 7 square root of 2. Alright? Now, again, please make sure that you have work similar to this in your notebooks so you know how to follow the steps on your own. Okay? Alrighty, now on your own, I'd like you to do the try these numbers 1 through 3 in your notebooks. Okay? Please do those in your notebooks, and I'll see you next time. Bye, guys.